Okay, hold your horses because I'm going to show you what is the problem that solves the derivative of a function. Okay, so we're going to start talking about derivative of the function, and in order to do that, the first thing we should know about it is obviously how to graph a function or how to think a function. So when you have functions, one cool part is that you can represent it in a graph. So I'm going to use an example of a function on a graph. But the most important part okay, it's not the most important part, but one key or something that we would like to talk or to check in a function is how the function is increasing or decreasing. Okay, so we can know just by checking any point, let's say this point. Okay, we can know by checking this point whether the function is increasing or decreasing. So for example, here you can see, okay, the function is going to decrease. Very good. But how is going to decrease? That's the question that we need to solve. Okay, so maybe you can tell, okay, I know that if I do this line that is tangent to the function, I will know by the slope how the function is increasing or decreasing. That's very nice. That's something very clever that people did when they're trying to figure out how functions changes or not. But the problem is how to calculate it properly. Okay, how to get the value properly. So in order to do it, what we're going to do is to start with the second. Okay, so I'm going to start with the second. Okay, so you can see that this line that I traced passes by 2 points of the function. It's not what I expected, but it's one line that has 2 points, x, and crosses by other point, x plus h. So, I mean, this line is between an interval of h. Okay? So, and the question is, okay, how we can determine the slope of this line, the second line. So, when it's x, I can say that the function is fx, and when it's x plus h, so I can say that the function is just f x plus h. Okay, so now we can use our typical algebra when you work with the slopes, with lines, and everything about that. Slope intercept form, lines. There's a video in YouTube about it, so you can check it. In which we have to determine the slope. So in order to get the slope, we just need to take the change in y over the change in x. So in this case, the change in y is this point, that is just the subtraction of the two values. And in x, this change is h, okay? And so essentially the slope of the second is going to be fx plus h minus f of x divided h. Okay, so this is how to calculate the slope of the second. Now you will say, okay, but this is the second and I want to know the tangent to learn how to increase or decrease the function. So in this case, what we're going to do is to approximate the second into a tangent function. So how to do that? What we're going to do is to change this x in order to make it very small. Okay, so we're going to decrease it to make it very small. So for example, let's say that I'm going to decrease x to this point. Let's see if we can do it. Okay, you see, if I decrease h to a smaller value, so I'm getting a secant that is more approximated to the tangent. So I'm going to make it smaller to get it the tangent. So the tangent that it's calling the derivative of the function, this could be the notation, or this, the derivative is just going to be the limit when h goes to 0 of fx plus h minus fx over h, and that will be the derivative of the function. So the derivative of the function solves the problem of the tangent or the slope of the tangent to a function, and is going to tell you how the function increases or decreases. That is something highly used in functions, because this is what you want to know in a function, not only the value but what's going to happen to it, because it helps you to predict the future. So this is how you use the derivative of a function. So I hope that you understand everything that I said. I hope that it was clear the context of the derivative of the function, and now you can practice with any function to get many derivatives of functions. But that will be in another time, another videos. You can comment what will be the derivative you want that I demonstrate on a video. And remember to follow me in my tube, follow me on any social network. You know that all my social network are FFIM, and you can follow me, write, type, comment, and see you in the next video. I hope you have an excellent day. Bye bye.